Lesson 5.2 is where things start to get sticky. It's about dividing polynomials, and I know if you're anything like me, well, a lot of you are better than me, but those of you who are like me, every time you see the word division, you just automatically think this is going to be crazy because division has always caused issues. We've already learned a version of dividing polynomials in Algebra 1. Hopefully you remember the reverse distributive property, which is that if this is a one term separated by a trinomial, that pretty much what you could do is simply split it. And I would definitely put the plus first, or in between. And then that way you can actually work these out individually like what we did last time, which is 15 divided by 3, which is 5. Again, I'm not going to go through all that stuff because we just did the review. X squared stays there. And again, 1y on top, 2 y's on the bottom, which means that there's going to be a y on the bottom. This is going to be negative 6. This is going to be an x. 2 minus 2 is 0, which means they cancel out. This is going to be negative. That's going to be 10 over 3 because there's nothing you can do to that, but it's reduced or simplified. And then this is just a regular y on the bottom, so I put it down here with the 3 because, again, 1 minus 2, there's more on the bottom. That is your answer. A very ugly answer, but there's nothing you could do. Now, there is a way to put that back into fraction form, but I'm not going to worry about that. Again, if you want to know that because for some reason you just love to learn those processes, I do not mind telling you, but I'm not going to put that in your notes because some of you are already looking at this and saying, wow, this is what we're doing, but actually it gets worse. So this problem might have a little toughness to it because it throws power properties, but as long as, again, you remember to split the fraction into its singular elements, it's not as bad as it looks. Again, the issue is that splitting the fraction only works when there is a one-term denominator. All right. The majority of your problems will not allow you that luxury because, of course, we're in six-weight algebra, so I'm not going to give you a bunch of one-term denominator problems. But again, as long as there is one term, you can simply split and do this work here and get your answer. But unfortunately, there's another thing that must be looked at. So hopefully you've been taught long division. If not, let's go over the steps to ensure the focus. If you don't know this, I would write it. The question we usually ask is how many times does it fit? Then we multiply by the number, and then we switch the sign, then we bring down the next value, and we repeat. So in other words, whenever we have this, we usually put 5 on the outside, and then we put 1973 on the inside. And again, I suggest you write this because as silly as it seems, this is actually going to come in handy and make things make sense later. So what I do is I ask myself, how many times does 5 go into 1? And yes, you're supposed to say 1. And it doesn't go into 1, so you move it over to 5 into 19, which is 3 times, and you put it over the 9 because it's going into 19. Then you multiply. 3 times 5, 15. Then you switch the number. Then you pretty much switch and add. Should be that part. Then bring down, switch and add would be bringing down 4. Then bring down the next value, which is your 7. And then you repeat. How many times is 5 going to 47? 9 times. And you multiply. 45, and then you switch and add. So switch and add, and then bring down the next number. And then how many times is 5 going to 23? 4 times, and then multiply, which makes 20, and then switch and add, which makes 3, and then you can't bring down the next value. So what we do, and I don't know how many of you know this, but it's a good experience for you, especially being in 6-weight, is that this is your numerator, and this is what you are dividing by. So it would be 394 and 3/5. Alright, that is the exact answer. You could put 0.6, and that's also the exact answer in this case, but it doesn't always round out to 0.6. But typically when you divide, your remainder goes over your number there. So that's why I suggest you copy this and kind of keep this handy, because if you understand that, then you can pretty much get this new stuff once you get used to the adjustment. Again, the process is similar when it comes to dividing polynomials, but the first step has a small adjustment. Instead of asking how many times does it fit, we'll say what is missing. So again, this is the general part still, but you want to, instead of saying how many times it fit, you want to say what is missing, because you actually want to make them match. So consider the terms 3x squared and 15x to the 7th. What is missing? First off, and if I want 3 to be a 15, I must multiply by 5. And if I want x to the 2nd to be x to the 7th, I need to add 5 more x's, because 3 times 5 is 15 and 2 plus 5 is 7. That is how you do it. If I have 2x going to negative 10x to the fourth, the first thing I notice is missing is that we need a negative, because it's got to be the opposite. Then I know that in order to make 2 into a 10, I must multiply by 5, and that if I have 1x and need 4, that I need 3 more x's. That is it. If you can do that, then you are 60% ready for long division, because for the most part, the other 40% comes out of just practice and messing up and figuring out what you did wrong, because it's really not that bad. You just have to practice it and actually trust the system instead of trying to figure out if there's an easier way, because there is no easier way for that. So notice our goal is to figure out what makes the first term match the second term. When we do our process today, we focus on the leading term of the situation. So this problem here is a division problem, and it's usually top divided by bottom, which means that what we will do is this goes on the outside. Again, when I usually see things, I think inside out, because you don't want to wear your clothes inside out, and I think that's inside, that's out. So inside out is how I read it, which means x minus 9 goes on the outside, and x squared minus 8x minus 19 goes on the inside. And so I am going to focus on this and this, first terms only. What is missing from here to here? And what is missing there is 1x, because the numbers are already there. And here's another rule you need to know, and you might want to write it for your notes. If there are 2 terms, your first number should go above the second term. If there were 3 terms, your first number should go above the third term, because this needs to fit into that. And so therefore, since we are getting just 1x, we put an x there. We then multiply. Remember that step said multiply, so x times x is x squared. X times negative 9 is minus 9x. Remember that step 3, I hope you wrote it down, is switch and add. So switch everything and combine. That goes away. This leaves us with x, and then bring down minus 19. Focusing on the front, what is missing? Nothing, which means how do I multiply x to be x? I multiply it by 1. Now I multiply. 1 times x is x. 1 times negative 9 is negative 9. I then switch and add, which means that the x's go away, giving me negative 10. And so my final answer would be x plus 1 plus, because we're adding our remainder on, and I would do it this way because otherwise it's going to mess things up, negative 10 over, remember what we divided by, which is x minus 9. And that is your answer. And yes, you are going to have a good amount of problems that have remainders, because what better way to do division than with remainders? I mean, that makes it more fun. For me at least. So again, that's what we're looking at. What's missing? Got my x minus x plus 1. I got a number left over with nothing left to put there, so I'll take this number and put it on top of that number, attach it to the other part with a plus. That's it. Here, 10x squared plus 7x minus 2 over 2x minus 1. So what I'm going to do is put my 2x minus 1 on the outside, and this on the inside. Once again, I will say, focusing here and here, what is missing? First off, I need a 5 and I need an x. There are 2 terms, so I will put that here. Now here is a beauty of this work, and you'll notice it as we go. When you follow the rules that I tell you, some things just happen to work out. For example, it's 2 terms, so we put it above there. Notice x is above the x. So if you ever get an answer and this variable does not match that variable, it means you probably messed up. Because, notice here, the x is above the x, the number is going to be above the number. Anyway, now you multiply 10x squared minus 5x. We switch and add. That goes away. That makes 12x minus 2, because we bring down the 2. And once again, focusing on the front, what is missing is 6. We don't need an x, so it'll just be plus 6. Multiply out here, 12x minus 6. Switch, add, and in the end we do 5x plus 6 plus 4 over 2x minus 1. So in my opinion, as long as you approached it with the right mind state, you should be at least seeing that this isn't so bad. Like, it's going to take some work and it's ugly stuff, but it's not as bad as what it seems. And then once you feel that, I'll show you the next question that makes you think, oh yeah, I knew he was going to do something silly like this. But that's really all it is to it, is make it match, multiply, switch and add, bring it down, and continue. And yes, even whenever you see a question like this, as long as you trust the process, it will be an easy question for the most part. First rule though, and again write this down in your notes, is that you cannot skip a variable in a system. For example, I can't write x squared minus 2. I must write x squared plus 0x minus 2. Just like if I was dividing by 1001, I wouldn't put 11 because I have 1 in the ones place, 0 in the tens place, 0 in the hundreds place, 1 in the thousands place. So those zeros are placeholders. This is a 3-term part even though it has a 0x, so you just don't write it. But that placeholder is important. Same thing for what goes on the inside. 2x to the 5th, and now you have to ask yourself, is there an x to the 4th? Nope. Is there an x to the 3rd? Nope. Is there an x squared? Yep. Minus 8x minus 4. Of course, I put myself all the way against the corner. It's always good to do when I'm on video forever. So again, same system though. The difference is there are 3 terms, and so I'll start above the 3rd term. But again, watch how that pattern holds. The only thing missing here is, oh, I'm sorry, I'm missing a 2 because I needed this to have a 2 on it. So 2 and 3 x's. 1, 2, 3, 1, 2, 3. And notice how it's going to be x to the 3rd. Guess what this one's going to be? X squared. Guess what this one's going to be? An x. Guess what this one's going to be? A number. And then you're going to have nothing left over and put in your remainder. So it's not overall ugly. It's not overall mean. It is just ugly. I'm sorry. Now you multiply. So you get 2x to the 5th plus 0x to the 4th minus 2x to the 3rd. You switch all your signs. You add your terms. That makes 0x to the 4th. Yes, we must put our 0x to the 4th. 0 plus 2 makes 2x to the 3rd. And then we bring down our next thing, which is plus 2x squared. Now we say, what do we need here? Well, obviously 0 is your number, but you need 0x squared, which we'll address later. Multiply. That makes 0x to the 4th plus 0x to the 3rd plus 0x squared. Yes, follow the rules. That way you stay consistent with your work. The thing is, after you switch this out, which really does nothing, you end up with 2x to the 3rd plus 2x squared minus 8x, which is back on track to where we need to be. What's missing here is a 2 and an x. And again, notice my x is above the x. Multiply here, you get 2x to the 3rd, 0x squared, minus 4x. Switch and add. You end up with 2x squared minus 4x minus 4. And in the end, what's missing here is just a 2. So 2 times x squared is 2x squared plus 0x minus 4. And look at this. When we switch it, this goes away. This leaves me with negative 4x, and this goes away. Which means my answer is 2x to the 3rd, plus 2x plus 2 plus negative 4x over x squared minus 2. Sorry about writing all that. Let me write that again so I can explain and make sure everything's clear. Remember, I don't need to write the 0x just like it's not over here. I just use it whenever I'm in the process. But if I did not put a 0 there, then it would have thrown everything off because I needed that 0 to keep things in place so I could continue the process. So again, the process can get ugly, but again, the key thing is making sure you practice it, because once you get it somewhat down, I mean, you're pretty much on the right track once you at least accept it as an ugly process and go from there. So try your best to stick to the process. There is no true shortcut. But similar to processes like the quadratic formula, once you hit a groove, you'll cruise through the problems because you step right through them. And I did just state that there are no true shortcuts, but there are short situations in which you can ease your workload as long as you have a divisor like the following. Divisor means that's what you're dividing by. x plus 5, x minus 8, x plus 2, x minus 1. Kind of like when you were solving by factoring. What's the solution here? It's negative 5. What's the solution here? 8. What's the solution here? Negative 2. What's the solution here? 1. Because if you set that to equal 0, you just kind of move the number and that's it. The process does not work with the following divisors. Here, because there's a number attached to x. Here, because there's a power attached to x. It only works when you have x plus or minus a number. Alright? Before I show you how to apply the process, let's investigate its repetitive simplicity. What we're going to have here is a number in what I call the silly box. And then you're going to draw a thing here. And the first thing we're going to do is, and I'll write this down, just kind of follow and make sure you understand how easy this is overall, even though we have to use a calculator probably. You bring down the first number, you multiply, you add, you multiply, you add, you multiply, you add, you multiply, you add. That's the process. Bring down, multiply, add, multiply, add. So pretty much bring down, multiply, add, multiply, add, multiply, add, multiply, add until you've reached the end, and that's that. So it's not a hard process, but again, it's just something that you need to make sure you practice and that you're ready for. So the rules are simple. Again, I would write this down. Bring down the first value, multiply by the box value, add. Repeat steps 2 and 3. Repeat steps 2 and 3. Repeat steps 2 and 3. The process of synthetic division starts by first identifying what I call the box value. Afterwards, use the coefficients of the dividend to complete the process. In the end, the last value on the list represents your remainder as you convert it back to its original form. Yes, you have to put it back in original form. Synthetic division does not allow you to just say the answer is 25897. It needs to be 2x to the third, 5x to the whatever. So here we go. We have a division problem. You already know you should be able to use long division on this, but looking at it, we can say, you know what? This is one of those things where Mr. Bradley said, if I can think about what the solution would be, what would make this 0 is negative 3. And then I go up here and I simply use the coefficients. So 2, x to the fourth, there's an x to the third, which would be 4. Is there an x squared? That's where you got to be careful. There is no x squared, so you must put a 0. There is an x, and there is a regular number, a constant. That's that. We then start the process. 2, negative 6, add, negative 2, 6, add, 6, multiply, negative 18, add, negative 13, multiply, 39, add, 43. And what I usually do whenever I do synthetic division is I draw that line there because that represents my remainder. But here's the beauty of it. There's a couple ways to do it. You could use this to know that since we start out as x to the fourth and we're dividing by x, that's going to be x to the third, or you can count up because that's no x's. I'm sorry, that's your remainder, so that's none, 0, 1, 2, 3. Either way, it should be 2 x to the third because again, it's going to drop down 1, minus 2 x squared plus 6x minus 13 plus, remember your remainder goes over whatever you divided by, which is x plus 3. Yes, I could have showed you that to start, and I know you want to punch the screen, but just remember it doesn't hurt me, it hurts you, so there's nothing you can do. That's just one of those things that I have to teach you the other part first because then you wouldn't listen if I showed you this way and you were like, oh, that's all I have to do, and then you wouldn't be ready to think. You have to use long division in most of the problems that you do, but whenever you have a situation like this, a x plus 5 or x minus 1, synthetic division is available as an option. So looking at one more, again, if you're taking good notes, this is where you should probably, if you feel like you know it, pause it, try it out, and see if you can do it. But the first thing we should do is recognize that this is a good situation. X plus or minus a number is good. Then you say, what number would I use? This is x minus 6, so I will use a positive 6. You then take your coefficients. 5, that's x to the fourth. There's my x to the third. There is no x squared. There is an x, and there is a constant. Bring down, multiply, add, multiply. That is 24 plus 180, which I believe is 204. add 204, multiply, this is 4 times 6, which is 24, plus 1200, so 1224, add 1227. Oh, this is going to be good. Let's see, 7 times 6 is 42, carry the 4, which makes 12, 16, carry the 1, 12, 13, carry the 1, 6, 7, I don't know. And then add, and I'm going to verify these, I just like to check my brain on occasion. 6 times 34, I got that one right. 204 times 6. Where did I get that from? Oh, I put times 4. Shouldn't sell myself short like that. 1224 does work, and then 1227 times 6 is, yes, I still got it. Anyway, that is your remainder. And then remember, the easy way to do it is, if that's your remainder, start at 0. So 0, 1, 2, 3. The reason we start at 0 is because our last term typically has 0 x's. So 0, 1, 2, 3, or again, count down from this one. 5x to the third plus 34 x squared plus 204x plus 1227 plus 7367 over, don't forget to where that's at, x minus 6. Beautiful job, beautiful work. The process of synthetic division would have worked on the very first answer that we did. Let me see if I can find it. Here it is, which was, and that's not it. Where is it at? Let me pause it and not waste your time. See how it just magically appears. So we got x minus 1 plus negative 10 over x minus 9. Let's see real fast. So we would put x minus 9, because remember this is being divided by x minus 9, which means that 9, or this is a good situation, but 9 goes in the box with 1, negative 8, negative 19. Bring down the number, multiply, add, multiply, add, remainder. This would be 0 and 1, so 1x plus 1 plus negative 10 over x minus 9. Of course, we don't put the 1 there. And again, look at that answer compared to this answer. X plus 1, negative 10. X plus 1, negative 10. So be sure to continue to fight. We only have 2 more lessons before you officially close out your first semester as a 6-weight algebra student. Good luck, and again, make sure you're asking questions. Make sure you're showing me your work if you want help, because I hope you are learning that when you show me your work, I am a very efficient tutor. When you want me to teach you what I've already taught you in the video, it's not going to happen. So other than that, have a good day and good luck.